recording right now. So everyone, this session is recorded, and I'm really glad everyone came today and is joining us for the webinar. Today we have Kimberly Tripp. If you don't know her, I mean, she's incredible, and I'm just really delighted to have her on here to give this session on statement execution and plan cache. If you have any questions, you can email me. I have an email here, rob@SQLtigers or www.sqltigers.com. So I want to thank, we have a sponsor now, Nutanix. Thank y'all for sponsoring us. They have a web link there. You can go check out their products. Wow, we got a little feedback. Kimberly, can you hear me?
I can hear you. I don't think that's coming from my end, but I'm not sure. There's a lot of static and feedback, but I'll mute again while you're presenting.
No, that's fine. I might be able. Okay, if you mute, let's see if that helps. Let's see if there's something I can do. Oh, wow, it went away. Well, we'll see how that works. Hi, so if you're going to Summit, I have a registration code here. Please use it, and if you use it and we get enough people that use it, we're going to give away a free conference, which is really cool. Last year we could do it. We had enough people come last year. Hopefully this year we'll have it too. So thank y'all for using it, the ones that have used it, and if you're going, please use it. All right. They have the Passion Awards, and if you want to nominate someone, you feel someone's done a great job for PASS, the link is right here, passionaward@sqlpass.com. I mean, it's an honor if you nominate someone, so please nominate them, and they could win it. Who knows? So with that, let me change it over. Change the presenter. No, change the presenter to. Okay, I'm changing it to Kimberly now, the presenter. Let's see if it works. I see the screen. Great. Thank you, Kimberly, again for coming. You may have to unmute yourself if you're talking.
There we go. So thanks, Rob. Yeah, this is great. I always love these presentations and working with user groups. Let me make sure it's got the right screen. Yeah, there we go. And I love working with these user groups and doing these presentations. I think they're great fun. I know it's a little bit strange to be kind of talking to no one for the next 60 minutes. I mean, I know you're all out there, but there's not a lot of direct interaction. I will try to watch the questions, but probably the best way to do questions is holding them for the end, and I am more than fine with sticking around for a little bit at the end of the presentation to make sure that I get through some of your questions and answer some of the things that you're maybe struggling with. So this is one of my favorite talks as well, because I think it's something that everybody needs to know, and I think there's a lot of confusion and misconceptions around how statements are executed and how the cache works with statements, and there's even some marketing that Microsoft has done over the years, and there are some great things that work incredibly well in some scenarios, but unfortunately one of the things that's been marketed isn't as exciting as maybe how the marketing has made it sound. So I want to make sure to clarify all of this and really make sense out of the way that you execute statements, because if you don't execute them correctly, then you're going to end up having one of two problems, really. You'll either have plan cache bloat, and this can waste your cache and cause you to use a lot of your cache in ways that you shouldn't, or you can have something called parameter sensitivity. And parameter sensitivity problems cause you sometimes massive performance problems. So it's really important to make sure that you get this right. Otherwise, you will have like I said, one of these two problems. So before I go into the technical content, I've got a few of the obligatory marketing slides. Our SQL Skills team is a group that hopefully many of you guys are familiar with. A lot of us are on Twitter, blogs on SQL Skills. We do classes both in person. We call them our immersion events. People sometimes say it's like drinking from the fire hose because we totally immerse you in content for 5 days, and we do these around the U.S. and Ireland. We've got online training through Pluralsight. In fact, I'm going to give you a way to get a free code for 30 days, and that will give you access to over, I don't even know how many hours we have up there now, but 130, 140 hours of content. So you'll definitely want to check that out, and there's no gimmicks, no credit card, things like that. It's just 30 days for free. We do consulting, remote DBA. I'll leave it at that. You can check out all that stuff on our website, and we do have an insider program. It's not a spamming kind of thing. We send 2 emails a month with all sorts of tips and tricks and things that we've seen on customer systems that might actually help you as well. In terms of our immersion events, we've got 2 of our core ones, Performance Tuning Parts 1 and 2, and if you're interested, all of these slides will be available for you to look at so you can get some insight or check out our website. I've been working with SQL Server for a crazy amount of time, actually. It feels like since 1989, actually. So 1990 was really when I got into things. 1989 was actually when Microsoft and Ashton Tate released SQL Server version 1.0 on OS2. But anyway, for the last probably 15 years or so, I've been doing a lot of more public consulting, training, speaking, writing. I used to work for Microsoft before that, and my area of expertise tends to be architecture, partitioning, looking at the overall design and structure of the database. But even if you do a good job at that, because I thought about the fact that this is the architecture virtual chapter, you know, even if you do a good job with your architecture, if you don't execute statements correctly, what's the point, right? So these things are more integral than I think a lot of people think. And if an architect does a great job, the question is, are there developers and, you know, coders, or even the way users are accessing the system, is that right? Because it can definitely undermine a good architecture. So I think it's really important to understand how all these other things affect your environment. So even if you're not a developer, I think it's important to know this even as an architect. So I don't know what roles everybody has here. I have one, I think, last marketing slide. If you're interested, we do have a show called SQL Intersection. We're in Vegas this fall. Yes, it is the same week as PASS. I realize that SQL Intersection also has a big developer show, so they don't really think of that as a clash. And we tend to focus a lot on architecture and development, whereas PASS I think of more as DBA. But anyway, you can look over the show, get some insight, and hopefully we'll see you somewhere, and hopefully you're getting good training. So that's all that really matters. Oh, and I forgot about the Pluralsight slide. Paul at SQLskills.com, if you send him an email that says PASH Virtual Chapter Pluralsight code, he'll give you a code. You don't have to put in a credit card or anything. It won't like auto sign you up or things like that. And there are lots of courses that you can access for free, including 4.5 hours on weight stats. I have an optimizing stored procedure performance. There's a DMV diagnostic quiz. I mean, that's just 3 out of, I don't even know how many courses we now have. Our full library is there, and I will give Rob a copy of this deck where all the links are active, so you'll be able to log in and check out these things, or click on the links and check out these things. So let me get into this stuff. Like I said, as an architect or even as a developer, there's a lot of things that interact and work on both sides that you need to understand. As either an architect, what is the developer doing, or as a developer, what has the architect architected, right? And we all know that as architects. We think about our partitioning schemes, we think about our table structures, and we sometimes have ways that the developers have to use to access our data to get the best performance out of it. I can give you a great example, actually. If you are doing things like partitioning and your developers are using stored procedures, it is actually ideal for them to use stored procedures with recompile, because even though the stored procedure will work against the correct partition properly, the estimates won't be ideal because of the first partition that was used when the procedure was first accessed. And that might not make a lot of sense to you yet, but my point is these two roles are way more integrated than I think a lot of environments even like to think. They don't think that DBAs and architects and developers have to communicate. And sometimes it's very siloed. And that, I promise you, is a problem. If DBAs, developers, and architects could communicate more, there are so many things that they could learn from each other. And if everybody knew even just the pieces that overlap or were really critical, you could solve a tremendous number of performance problems. So I always recommend to my DBAs to do cross-training to developers. I recommend developers to talk to DBAs to get insight into things that the DBAs have learned when they have done operational, changes or automation, because that might affect, the type of code that somebody's writing. And there's just so many interactions, and that's one of the things I'm going to talk to you guys about today. So if you are an architect, then I want you guys to talk to some of your developers about some of the issues that they might be running into. If you're a developer, you might want to go back to your architects and talk to them more about the structures so that you are accessing them correctly based on some of the tips and tricks I'm going to tell you today. But you might need to get more information about the data to do that job better. So it's really important for everybody to communicate. But I will stop singing Kumbaya and I will move on to the content and just dive into the statement execution. So some statements, the way that you execute them, they do get cached, they get reused, and everything sounds good. But that doesn't always happen, and in fact it doesn't happen as often as you might think. So I want to start by talking about the different ways that you can execute statements, which types of statements will be cached and reused, how auto-parameterization, if you haven't heard about that, how that works and what some of the issues are and requirements are. We'll talk about dynamic strings and how they play into this. I'll compare and contrast dynamic strings against SP execute SQL, because a lot of people think that they're the same, but in fact they are very, very different, and it's really important to understand their differences, especially in terms of caching and automation. Hey Rob, you guys might want to mute your mic. I think we're hearing you guys. I'm not sure. I think Kenny, you don't show as muted.
So I'm going to go through here and kind of mute everyone.
Okay, just as long as you don't mute me.
Yeah, well, there's a lot. As you see, there's quite a few came under your ID. So I just muted everyone but the organizer. So I think we got. Okay. How's that sound?
Yeah, that's really weird. I don't know what those all are, but okay. Oh, maybe they used my link. No, because I just gave the link out of the regular. Well, anyway.
Well, I think we're good because I muted everyone. Okay. So.
Yeah, it's just I can hear a lot of feedback and a lot of kind of rustling, and I don't know if the attendees can hear that. So I was just checking. So, but anyway, okay. So I'll definitely compare and contrast dynamic strings and SP execute SQL. And since I always, when I'm doing this and very much so interacting with folks, they start asking me about stored procedures, I'm going to throw stored procedures into the mix and make sure that those make sense. I'll kind of bring together the difference between literals, variables, and parameters, and what those are and why they're different and how they're different, which I think is the most important. We'll talk about the plan cache limits because of how long a plan stays in cache, and I'll bring it all together with a bunch of tips and tricks. So that's our session, and I am going to go about an hour till 11, maybe a little bit after 11, and then I'll stay for questions, just to remind you guys that I'll stay at the end for questions. Okay, so As far as the different ways to execute SQL, a lot of you think of ad hoc statements. Ad hoc statements would be kind of like you're sitting in Management Studio, you're typing in a select, you send that off to the server. That's an ad hoc statement. Applications can send ad hoc statements as well, but often applications do things a little differently, but not always. But an ad hoc statement might become what we call auto-parameterized, and I'll be very clear on what that means in just a moment. Now, another type of statement is actually just an ad hoc statement, but it's called a dynamic string or dynamic string execution. Some of you guys may have used this by putting execute and then a string in, let's say, a stored procedure, maybe inside of some application code. That is what we'd call a dynamically constructed string, but ultimately that string is then turned into an ad hoc statement. So for all intents and purposes, these two are really the same, right? Ad hoc statements and dynamically constructed strings look the same, act the same, behave the same. So everything I say about an ad hoc statement is going to apply to a dynamically constructed string. Now, on the other side of things, there are statements that are built dynamically even. Some people call these dynamic strings, and they pass them into SPExecute SQL. I personally like to differentiate between dynamically constructed strings that are executed with execute versus dynamically constructed strings that are executed with SPExecute SQL. So I usually call SPExecute SQL statements forced statement caching. And I'm going to be very clear again on what this means in a moment. This is exactly the same as really how stored procedures work. Okay, so when you send something in an SPExecute SQL statement, you're kind of turning that into a stored procedure. It's not really, but in terms of caching, SQL goes through, looks at that statement, comes up with a plan, puts it in the cache, and reuses it. That's what a stored procedure does. So I really want to clarify exactly how it works with SPExecute SQL, but ultimately SPExecute SQL and stored procedures behave the same way. And this is also true for some of you in your applications that send statements not as just an ad hoc statement, but use some type of client-side caching mechanism that allows you to create what are called parameter markers. And when that statement is built using parameter markers, you're building a statement just like SPExecute SQL, but you might be using SQL prepare, SQL execute, SP prep exec. Like there's all sorts of different mechanisms for preparing queries, but all of these three all work the same way. So when I start to talk about the pros and cons, there's really only two ways that statements are executed. They're either ad hoc and they work one way, or they're a forced caching mechanism, and I'll show you how that caching mechanism works. So it's really important to understand that these things in these sections behave the same way. Now, one little clarifier in the box that I put at the bottom, even though stored procedures behave the same way, there are things that you can do, because I generally expect a stored procedure to be more complicated code, not just one line. But you know, you have literals, you have parameters, you have variables, you have dynamically constructed strings. You might even have SPExecute SQL inside of a stored procedure. So it'll be kind of interesting to expand a little bit on how stored procedures work. And I'll do that very briefly, and at the very end of the session I'll point you guys to some other presentations that I've done where I go into a massive amount of detail on how that works, how to tune it, how to deal with it, and so forth. So, all right, let's start with the types of statements that can be cached for reuse. Ad hoc statements, or dynamic strings, which are ultimately ad hoc statements, they're evaluated at runtime because they're not even built until runtime. Right? Or an ad hoc statement is just the statement. But that statement is now going to SQL Server, and SQL Server starts to analyze it. And there's a point during that analysis where SQL Server says, is this statement safe or not? And if a statement is incredibly simple, and it really does have to be very simple, then it can be deemed what we call safe. And when it's safe, it can be parameterized automatically by SQL Server and cached, and then on subsequent executions, SQL can reuse that plan, which is fantastic, right? If they can reuse the plan, that means they don't have to use CPU time to check and regenerate a plan. It means that there's less in cache, so a smaller footprint in cache. So this is a very good thing. In fact, from a marketing perspective, I can see why they're, very excited and have been very excited. I mean, we've had auto parameterization for a long time, but, they made a very big deal out of it when it first came out. Auto parameterization is really good. And I totally agree. When it happens, it's great. It's absolutely great. Now, there is one very small amount of kind of bloat that's created, but it's very minimal. I call it prepared plan cache bloat, and that's when you have a statement, like look at the bottom of the screen, select star from whatever table, blah, 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 or hopefully not star, but you've got some select from some table, and then the most important here is where the parameters are, where the conditions are. So where member number equals 12. Well, internally, SQL is going to turn that into parameter 1 is a tiny int, and then it puts into that statement the @1 as a placeholder. So now that's what gets cached. Every time somebody executes that same statement with a tiny int, then we'll use that plan. Now, if somebody executes it with a small int, they'll get that plan. When somebody executes it with an int, they'll get that plan. The problem is that those are probably the same plans. In fact, almost positively they're the same plan, because the only types of plans would be simple trivial plans anyway. So all three of these are probably exactly the same plan. So instead of having 3 in cache, it would be nicer if we only had 1. So this is what I mean by a very small amount of prepared plan cache bloat. Okay, so that's not horrible. But what is kind of frustrating is that most statements won't be parameterized. And let me rephrase, that's actually not entirely true. SQL Server pretty much always parameterizes, but then when they hit that fork in the road and they say, is this safe or not, they will only store for reuse in cache statements that are safe. So the statement's parameterized, but largely most of your statements won't be safe. And because most of your statements won't be safe, they're not going to go into cache in their parameterized form. So what'll end up happening is you'll end up having plan cache bloat from the ad hoc statements, and then you will have to recompile on every execution because there's no cached plan waiting for you. And you might think, oh, okay, so when is a statement not going to be safe? And unfortunately, there's a tremendous number of limitations. In fact, I'm sure some of you have already read ahead a little bit, and that first bullet almost makes me not really laugh in a happy way, but kind of laugh in a oh kind of way. One of the biggest limitations that I think is crazy is that the from clause cannot list more than one table. So if you have any statement that is referencing more than one table, then it won't be safe. So that statement will never be able to be cached using auto parameterization. So the only types of statements that can be cached are statements that reference a single table. Okay, but even if it references a single table, look at the other bullets, right? The where clause cannot have an or, the where clause cannot have an in, the statement cannot have any subqueries. I mean, and that's only 4 of the, I don't know, 20 or 30 restrictions on a statement being safe. In fact, if you read a little bit further, only very trivial statements can be parameterized and safe in the cache. So it's really important to realize that most of your statements are not going to be parameterized. They're going to have to be, compiled, and a plan is going to have to be generated on every single execution, which is costly in terms of CPU and in terms of time. So what we need to think about is, how can I put statements in cache so that they do get reused? but even then, you don't want to just shove stuff in the cache for reuse if you don't understand what kind of impact that plan might have on subsequent executions. So it's really important to understand when a statement should be cached. So let's dive into this a little bit more. I do have a little bit more detail. It's a little bit more complicated than even I've described. Everything I've described so far is called simple parameterization. And in fact, simple parameterization means exactly what I've said. Most of the statements that you are executing in an ad hoc or dynamic string are not going to be safe. They're not going to be cached. They're not going to be reused. They're going to cost more CPU, but they are going to get a new plan on each execution. Now, is it a different plan? Maybe, maybe not, right? Now, there is a database option that can change this behavior. And before I even tell you about it, I want to stress that I rarely turn this on. And if somebody is telling you to turn this on, I would say before you turn this on, do some testing and some analysis to see if this is a good idea. Now, I put in the recommendation that you can see in that third sub-bullet here, you can investigate whether or not your plans are stable by using what's called query hash and query plan hash. So before I go on, because now I'm getting a little bit deeper into this, when you execute a statement, that statement goes into your cache. That statement does get what we call a query hash. And if you execute a statement with different parameter values or different literals, let's say, those literals are kind of normalized out before the query hash is generated. So even if those statements are in the cache thousands of times because the statement's not safe, those thousands of statements will have the same query hash. So I can look at the cache, see that I have 1,000 statements in the cache that are the same, just with different literal values. And the beauty is I can then check their query plan hash. So not just their query hash, but their plans hash. And if I end up seeing that their query plan hash is the same, then I know for those 1,000 statements, I have one plan. And if I have only one plan for those 1,000 statements, what I know is that even though SQL Server didn't deem those statements as safe, that they are in fact stable. So I use the term stable to talk about plan stability. Is that plan stable across all of the parameters that you're using? And if you have good plan stability, then you could consider forced parameterization. But you can't find out after you've turned it on. You really have to analyze for this before you turn this on. So how many times have I turned this on? Probably only 4 or 5 times ever. So I really want to stress it's not super common, and a database has to be incredibly well-tuned. You have to have incredibly good indexes and incredibly consistent access methods. And that might sound confusing, but what I mean by that is if the application has a very kind of consistent pattern with the way that it's accessed, then it's more likely to be a candidate for this. But if the way the data is accessed is all over the place, then it's even less likely. So that's why I keep saying that this is generally not recommended. But ultimately, if you turn this on and you have very stable plans, then you can significantly reduce the CPU from having to recompile all the time. But the problem is if you force SQL to parameterize statements that it should not have parameterized because their plans aren't stable, then you can actually go the other direction and have worse performance because of something known as parameter sensitivity, meaning that first plan that does get put in cache might not be good for all of the subsequent executions. So you could end up executing bad plans. So I'm not a fan of this. I think you really have to be careful before you even consider this. So that's all I'm going to talk about in this seminar on plan caching and forced parameterization with the forced option, but if you check out the Pluralsight course on statement execution, I do have a much larger section in there where I kind of go and discuss different options. And again, if you send Paul an email to get that Pluralsight code, you can actually watch that for free. So definitely something to consider. So if a statement is parameterized and safe, the good news is it does get reused. But if the statement is unsafe, then every single execution is going to have to be compiled. Every single execution goes into the cache for something called textual matching. And all of this stuff can end up leading to plan cache bloat and wasted CPU. So that's why we really want to look at other options. Now, just to be very clear on dynamically constructed strings, a dynamic string is a string that's not evaluated until runtime. Those values that are usually in variables are not set until runtime, so the string is not known until runtime. And it allows you some incredible flexibility. If any of you work in an environment where dynamically constructed strings are absolutely not allowed, I feel kind of sorry for you. Now, I've seen the other side where like people go crazy and they want to put everything in a dynamic string. That's not what I'm saying. But there are some cases where a dynamically constructed string, if it's well constructed, if it's well tested, if those who are writing it know how to radically reduce problems like SQL injection, then you can do this very effectively. So I am a fan of dynamic strings. If you don't know anything about how to tweak and fix dynamically constructed strings, I do have a blog post, and I'll see if I can throw this up here really quick. It's Little Bobby Tables. I don't know how many of you, it always makes me laugh still, even after this many years. But I don't know how many of you know Little Bobby Tables, but I wrote a blog post called Little Bobby Tables, SQL Injection, and Execute As. And it's a long blog post. I personally don't blog very often, but when I do, they tend to be very large blog posts. And I go into a lot of detail here about how to do dynamically constructed strings and do something that I talk about 3/4 of the way down into this blog post on how to use a loginless user so that you can really reduce the permissions associated with a stored procedure that might end up having a dynamically constructed string. So I'll leave this as kind of homework if you want to use dynamically constructed strings, and there are some cases where dynamically constructed strings can be very effective. So I don't want you to rule them out entirely, but they're not my go-to. I don't use them all the time. Okay, so I'll give you a bunch of resources, but this is one of them for sure. Okay, so all right, a couple of things just to mention them. These dynamically constructed strings can be incredibly large, and it works. Like I'm kind of amazed sometimes at the size of the strings that I've built that actually work. So I want you to know that these can be very, very useful. But they can be complex to write. You get into quotes within quotes, and sometimes there's 4 or 6 or whatever quotes in a string, and you kind of start to lose your mind. So they can be complicated to test and write and so forth, but there are some good uses. But I want to stress more than anything else, a dynamically constructed string, you build that string, and when you send it to SQL Server, you are sending it an ad hoc statement. So the string that is built and then executed with exec is an ad hoc statement. That is very different from SP-execute SQL. Even though you're building a dynamically constructed string, with SP-execute SQL, you've got, first of all, something I really like, which is strongly typed parameters. And those strongly typed parameters are then part of the parameterization that is used when the statement that you've sent with SP-execute SQL gets cached. Because SP-execute SQL is not an ad hoc statement. It is a way of accessing a forced statement caching method. So I'm going to show you this. In fact, I think now is a good time for a demo, and I will give you guys this script so you can play around with this. I'll bundle it up with the resources. I use a sample database called Credit, and Credit is just a simple kind of, members, customers type of thing. It's pretty straightforward, and I'm going to end up using just a couple of tables, like I'm finding customers in the members table. Now, to show you how things behave, I want to make sure that you are not on a production system. I mean, come on, I don't know if I really need to say that, but unfortunately, I do get some people that are like, well, we didn't have a test environment. Well, if you don't have a test environment, you put developer on your machine and you use that. Like, you never want to mess with some of these things in production environments. But I'm going to check my configuration option for optimize for ad hoc workloads, and you're going to see right here that the value in use is 0. So I do not have this set. In general, I recommend that almost every server have this set, okay? But the problem is, if you set just this and you don't do anything else, then you could have other problems. I mean, this is the thing that you always have to kind of realize. Every option has trade-offs, and you have to kind of know the pros and the cons and understand when it's a good thing to set, when it's not. I mean, generally, I recommend that this be on. So I'm recommending that you turn this off just for this script so I can show you how the default behavior works, and then I promise I'll clarify what happens when you turn that option on. I don't really need to have reconfigured my server because it was already configured correctly, but I just went through the motions of those first few steps. If you don't have Credit already because you haven't watched maybe a SQL skills presentation, I've got a link in there to the resources, and like I said, I'll give Rob these scripts to bundle up and put on the website as a zip for you guys. So I'm going to use Credit, turn my IOs on, and I'm going to look at a statement here that's updating a row, and I'm doing that just so that I have a simple row that I can find later. So I set the last name to Tripp, and I'm going to create an index so I can find that row really quickly. Credit by default has very few indexes, kind of on purpose. It's not super tuned. We tend to use it when we're showing people tuning strategies. So now if I want to look at my indexes, I don't usually use SP Help Index because I like to see more than just the stuff shown in it. So I use kind of my rewritten version of SP Help Index. You can see my index IDs, my index names. Here's the index I just created. It happened to get index ID 4. All of my indexes are enabled. It's a non-clustered index on last name. There's no included columns. There's no filters. And then I can actually see the structure of my index over here. This is a little bit beyond what we're talking about today, but there we go. So I can see my indexes there. I'm happy. Now, what I'm going to use is a query. Well, let me show you the query first. This query here to see what's in cache, right? I want to see the text, the number of executions, and then I want to see all of the stuff from the QS table. I want to see all of the stuff from the P table. So the QS table is my DM exec query stats. So QS is query stats, and P is my plan, DM exec query plan. So I want to actually see what's going on. Since I'm going to do that so often, I'm going to put that into a stored procedure just to make my life a little bit easier. So now, just so there's not a lot of stuff to confuse us or clutter, and plus I've been playing on my machine, so I don't want anything that's already there to kind of confuse the discussion. I'm going to make sure, so I just cleared cache. I just cleared my plan cache, not my buffer pool. I don't think there's really anything that's interesting in my buffer pool, but we're not looking at time so much as, in this case, as whether or not the plans are cached. So statistics IO, statistics time I use a lot. You may also want to turn on the graphical show plan right up here, right? So I'll turn those on, making sure everything's on. Now, all right, so here's a statement similar to what I showed you on that first slide. If I select star for member where member number equals 258, right? I run that, I go look at the plan says it does a clustered index seek, and that is because member number is my clustered key. So this statement, you really can't get much simpler than this, really. So if I run the statement for 25888, well, what's interesting, I don't even have a row, but of course SQL has to check to see if I have a row. And you can see here it does the same thing, a clustered index seek. And you might even look at the statement up here at the top where it says select star from member where member number equals @1, and you might think, oh, that's a parameterized statement that's been cached. Well, okay, in this case that is true, but just because you see the parameter there does not actually mean that it was safe. Okay, it's important to realize that. That's just the parameterized plan, not whether or not it was cached and whether or not it was reused. That we're going to have to look at another way. I'll show you that. I'll run this again for member number 48, and I can see again I get a clustered index seek, again I get the @1. I mean, some of you might be thinking, okay, I just ran that statement 3 times, so I should have one plan in cache that was used 3 times. But if I go and I look at my cache, what you'll actually see is, did I even, hold on, I thought I did run that. Oh, 25,888 is not an integer, it's a small int. So sorry, I must have changed that at some point, but how funny. I was like, why am I not getting one? All right, but anyway, let's look now. There we go. I'm not losing my mind. How funny. That script I must have tweaked something at some point, but there we go. We've got an integer, a small int, and a tiny int, and then of course you can see that I ran my small int a couple of times because I did run it once, then I ran it with the 25,000, and then I thought I hadn't run it, so then I ran it again, so that was 3 times. But you can see if I do run the same data type, I get reuse of the same plan. But with different data types, I get a different plan, different plan, different plan in cache. However, this plan, I just said different plan. I should say an additional plan, an additional plan, an additional plan. But if I scroll way over to the query hash and the query plan hash, remember I mentioned this, I see that all of these statements have the same query hash, and they also have the same query plan hash. So really, SQL Server determined the statement to be simple, it determined it to be safe, it ended up saving it in the cache, and even ultimately, all of the different parameter values end up yielding exactly the same plan. So I really don't need to have 3 of these in the cache. I really should just have 1. And you might think, well, what's the big deal? Well, okay, I agree with you. This is a pretty small plan. It's not that big of a deal. But imagine if your data type were something like a decimal, you know, where it was an 8,3. And so they could put in all of the different combinations of an 8,3. I mean, it's crazy how many copies that you could end up having in the cache. So I would much rather strongly type the statement so that I only end up with 1 copy in the cache, like this. I mean, this is going to be something that you're going to have to get your developers to do and rewrite, but notice that I say convert to an int 258. Let's do a bigger number here. Convert to an int 52,888. Convert to an int 48. And if I run those 3, right, of course I don't have a row for that middle one, and I check on cache this time, I immediately see, and we have to find the right statement. There's the convert one, and there's 3 plans. Okay, so instead of having 3 different copies, I now have 1 copy that has been strongly typed. And you know what I'm also going to do? I'm going to save this so the bigger number is in there for you guys when I zip up these scripts. Okay, so all of those have been deemed safe, they've been auto-parameterized, they've been cached, and they can be reused. Again, sounds great, right? Now, what about another statement? What if I say select star from member where last name is Anderson, right? Of course, what comes into mind here is Mr. Anderson. All right, so I run my select star where last name is Anderson. Notice this one doesn't look much different. So I'll run that one. Okay, actually it looks equality Anderson. Okay, I'll do another one here. M dot star with an alias, last name equals Anderson. So I'm just kind of running different kind of copies. And you might wonder what's different about this one and this one. That space right there. There's not much. Okay, I don't even know if some of you guys even noticed that one because it doesn't seem significant at all. And I agree with you. However, SQL does see that as significant in terms of what they call textual matching. So these two statements are actually different for textual matching, but they will generate the same query hash. So that's good. So when you analyze cache, they will give you the same query hash. This one won't match for textual matching, and it will not match for query hash. So that's kind of a bummer if you ask me. I wish that they would normalize the aliasing as well, but obviously that would get more complicated. So it's one of those things. So if you've got different aliasing, then these statements will look different in terms of their query hash. In fact, you know what? Let's put Anderson into this. I won't save this. And we'll just do a quick check on cache right now so you can see what I mean. So you can see that these three statements are in the cache, and I guess I did have an extra space in front of this one when I ran it, but it doesn't entirely matter. That's not nearly as significant as the M. Although, if you're wondering, I'll run that just to prove my point, and I'll go back and I'll do that. And now we'll look. Okay, so now this one lines up, but it just has the difference, which is the aliasing, which is different than the one that has the extra space, right? Which is different from these two, and these two only differ by this little tiny space here. So what's interesting is to end up seeing what their query hash and their query plan hashes look like. So you remember I told you that those two in the middle would have the same query hash. The statements that have the same aliasing have the same query hash, but of course they don't have the same query hash as the two ad hoc statements, right? The two statements that don't have the aliasing. But notice all four of them have the same query plan hash. So even though SQL didn't see them as safe, did not parameterize and reuse them, they really could have, because this particular query plan is safe so far. That's the key, so far. What if I keep going? Everything has been with Anderson, right? So you would expect the plan to be the same. What if I throw in a different value, like I throw in Tripp, right? And this one is an equality-based case, right? And in fact, maybe before we do the next one, let's grab all the ones that have last name now. All right, so now we've got the Tripp case, which looks exactly like this one, right? I mean, and you would argue they are exactly the same in every way except for the literal. So what do they have? Good news, the same query hash. But they have a different query plan. So what that tells me is actually that it was a good thing that SQL Server did not automatically cache and parameterize, because then Tripp wouldn't have had the option of getting a new and different plan. So to be honest, this statement, which is not simple, which is not safe, should not have its plan saved. So I think SQL did the right thing. I totally agree. And in fact, I can kind of show this and exacerbate this further by running, select where last name like Tripp, select where last name like TRI, select from last name where last name like %E%, run these three, which notice the first one gives me one row, the second one gives me one row, the third one gives me 4,999 rows. I mean, just to show you, I wasn't going to show time or anything, but you can see 4,999, one row, and look at the plans. They look different. The first two used indexes, or they used the index on last name to look up the trips, and the last one did a table scan. The reason that SQL was able to do that is that this statement is not cached. It's not safe. SQL is able to compile and come up with a new plan for every execution. And just to prove that with our cache information, we can kind of expand this a little bit further. Let's find the likes. Okay, so like Tripp, like %E%, and like Tripp there, lines 1, 2, and 7. And we scroll all the way down, and I know we're starting to look at a lot of stuff, but 1, 2, and 7, right, they don't match any other query hashes or anything, right? They don't match any query hashes. But interestingly, I've got some plans that are the same, right? There's some plans, right, that are the same. Here's a different plan, but the same, right? So 1 and 7 had the same plan, and whatever this one is, 6 has a different plan too, okay? That's an equality-based one. So, all right, looking at all of these, what we've just gone through, let me go back to the slides to make sure it's really clear, okay? Everything I've done was really ad hoc. Now I want to compare and contrast it with SPXQ SQL. So going back, a dynamic string or an ad hoc statement, they don't get evaluated till runtime. SPXecute SQL is to force the cache, and that's my next one. Okay, I want to show you that. Okay, now if you've never used SPXecute SQL, it might look a little bit strange to you, but the way that I do this is I usually declare a variable for the string itself, and then I build that exec string. That string is right here. It's usually way more complicated than this. And then SPXecute SQL with my string, whoops, and then my typed parameter list, and then the values. So it's not too complicated, especially with one value. It gets a little bit more interesting, and I've got some other scripts. You know what, I'll write a note to throw in advanced SPXecute SQL examples so that you guys have them. There's definitely a lot more that you can do with this, but I'll run this statement, execute, and you see the one row, and you see the clustered index seek, nothing exciting or new here. If I run it again, okay, I see my one row, I see my clustered index seek, again, nothing exciting. I'll run it a third time. But the question is, and of course this last one doesn't have any rows, but the question is, what is in the cache, right? So this time I'm going to look for MNO, because that's a nice placeholder for me to find, and I see just one thing in the cache. I love SPXecute SQL because when you have a nice stable statement, you are going to radically reduce what goes into the cache. There's only one copy that goes into the cache in its entirety. There's no ad hoc version that goes in for textual matching. There's no prepared plan cache bloat with different values because of different data types. I mean, you have strongly typed parameters and one plan and cache that everybody can reuse. So I really, really like this, but the problem with this is that you can't just do this for everything. And this is the frustrating part, right? Sometimes people want to know which is better. Should I use exec or should I use SPXecute SQL? And unfortunately, the answer is it depends. There is not a single right answer. Sometimes it is much better to use SPXecute SQL, and that sometimes is when you have a very stable, very consistent plan that does not change when the value to the literals change. So for anything that's stable, I absolutely, totally recommend using SPXecute SQL. But when something is not stable, this can cause you problems. So let me show you. If I go back to the other statement I was showing you, select star from member, where last name is like the last name that we pass in, and with a like, we could pass in Tripp, we could pass in Anderson, we could pass in %E%, TRI, right? Let's run all of these. So the first one I'm going to run Tripp. That is what's going to say, okay, use an index to look up last names. The next one won't have any choice now. It's going to use an index. The next, and you might think for Anderson that's okay, but it turns out Anderson is not very selective. It's actually not a good idea to use the index. But I'll run these other two, and you'll see they both used an index. In fact, one of my favorite things to show you, let me show you all three. And I'll go to the execution plan, and it tells me 33, 33, 33. So some of you might think, okay, they're all exactly the same. They all took 33% of the cost of the batch. Well, let's look at the messages window for a second. So here's what I executed, right? Tripp, Anderson, and %E%. So the first chunk essentially goes to here. Actually, it goes to here. There we go. So that's the first statement. It did 4 IOs and essentially took 52 milliseconds. Now, all of these statements are really fast. I would argue time is very hard to measure on a laptop where I'm running PowerPoint and other stuff in the background, especially when it's measured in this few of milliseconds. But anyway, the IOs are going to be super interesting. So the first one did 4 IOs. It used an index. It was very efficient. The next one essentially goes to here. Actually, it's there. Okay. There. Okay. The next one did 773 IOs. And okay, it only took 123 milliseconds. I mean, I know nobody's going to notice the 123 milliseconds, but the 4 versus 773 should definitely be a clue that the plan is not the same, right? And then look at this last one, right? The last one ended up taking 166 milliseconds, which again, that's not a big deal. But look at the IOs, 10,025. I don't know about you, but 4, 773, and 10,025, it's not 33, 33, 33, right? So my point is the execution plan that they're showing you is the cost of the compiled execution plan, not the cost of executing it. And the reason why that's so important to understand is that these percentages are not going to be accurate if you are not looking at something that was compiled for you. And one of the things that you can see when you click inside of that plan at the select is you can see the parameter list. And the parameter list, I'm just going to zoom that in just to make sure everybody can see that. The parameter list shows the column and it shows the compiled and the runtime values. So this first one is probably pretty good because the compiled value and the runtime value are the same. When I go to this one and I look at its parameter list, I see Tripp and Anderson, and that's a little bit hard to understand, but Tripp is highly selective, Anderson isn't. And one of the ways you can see that as well, if you look at the estimated number of rows, I'm going to zoom in on this one too. If you look at the estimated number of rows of 1.96, that is very different than the actual number of 385. This is not a statistics problem. This is a parameter sensitivity problem. The plan was compiled with the value of Tripp. Tripp had an estimate of 1.96. We just ran this with Anderson. Anderson has an actual number of 385. This statement is parameter sensitive. And because I forced SQL to cache it, I am getting a bad plan for my subsequent executions because the parameters need different plans. I love this demo. I think it clarifies so much of what these different things are. I'm going to skip back to the slides for a second here because I've really hit what I wanted to. There's actually some other stuff in that script that you could play around with, but the thing that I want to stress is most people have only heard about this concept of parameter sensitive problems in the context of stored procedures. But stored procedures And the way they're cached is actually the same as SPExecute SQL. We just happen to go that direction to get to the same conclusion. On the first execution, a stored procedures plan is cached. On the first execution of a statement that's executed with SPExecute SQL, hard to say, that statement is cached. And when the parameters don't warrant a change to the plan for it to be optimal, then this is great. This is absolutely fantastic. For a nice, stable statement, I would absolutely positively recommend using SPExecute SQL. You save compilation, you save CPU, you don't bloat the cache. However, if you throw a more complicated statement into SPExecute SQL, which really does need a different plan with different values, then this could be horribly bad. You can get very bad plans in the cache. In my case, I had this little tiny simple plan that wasn't even that noticeably bad, but it went from doing 4 IOs to 10,025. So definitely not the right way to do this. So I need to understand that I should not just use one or the other. I can't just always use Adhoc because that bloats the cache and puts too many copies in the cache. And I don't want to just switch everything to SPExecute SQL because that will force statements into cache that maybe shouldn't be cached, and I get plan cache bloat. So I need to use SPExecute SQL for things that are safe, and I need to use Adhoc for things that are not safe. So now, how do literals, variables, and parameters all weigh into this? Because everything that I've shown you so far has been a literal, right? It's where I've hard-coded, like member number equals 12. A variable is where you've got kind of the @ sign, and you're assigning the variable. Some of you might not know that you can assign in the declaration. You can assign with a later set or select, but then you use that variable in the select. The problem with a variable is that at the time that SQL Server optimizes, which is before execution, the values in a variable will not have been assigned yet. And because they haven't been assigned, the statement itself isn't going to be able to be fully optimized because they are going to look at that variable as an unknown value. And as a result, SQL can't do as accurate of estimation with unknowns. It has to use an average rather than something that's more specific for that particular value. So what I generally say is literals can be optimized and are deemed known values, whereas variables are unknown and we cannot optimize, so we have to use an average to get an estimate. And an average might be okay, but it might not be great. So I can't say whether or not it's good, it's bad, it's not always good, it's not always bad. It's just, it's what SQL does when it doesn't know what the value is. I mean, it's like if I ask you guys, how many of your products are red, right? Well, okay, you might know about your products, but what if I say, how many of your products are some color I'm going to tell you about later? Oh, that's harder, right? I mean, if we don't know what color we're talking about, the only thing I can say is, well, what is the average number of my products by color? So if I have an index and if I have statistics for color, you know, I might have 1/4 of my products are red, 1/4 of my products are yellow, and then let's say I have a whole bunch of other products of different colors, but they're all like 1/20th of my data. The average might be 1/8 or something like that. So if we get average, we'll get 1/8, but 1/8 isn't really good for red or yellow, and it really isn't good for the ones that are like 1/20th because it's just an average. So average can be good when your data is relatively evenly distributed, but when your data is not evenly distributed, average might actually not be good at all. So that's a tough one. But literals are known, they can be optimized. Variables are unknown, they can't be optimized. Parameters, they look like variables, but they're in either a declaration like SP executes equals declaration or a stored procedure. And since I've already shown you SP executes equal, I wanted to show you a stored procedure here. So I've got at parameter 1, and then inside the code, I actually have a variable as well. So select star from member where member number equals at MNO, that is a variable that cannot be optimized using the value. It can only be optimized using the average. Where member number equals parameter 1, that is known at runtime, and that can be optimized. So there's some cool things that SQL Server can do, but it's really important to understand what can be sniffed, what can be optimized, and what cannot. But no matter what, if the parameters are sniffed, you might get a more accurate estimate. The variables, even though they're not sniffed, you're gonna get an estimate. And that is what's going to dictate the plan. That plan, if it's cached, is going to end up getting reused for all of the subsequent executions. So how long is that plan going to stay in cache? And I've only got about 5 more minutes to go to wrap up, just so everybody knows, and then I will stay for questions. But how long is that plan going to stay in the cache? Well, it depends, but a while is maybe the simple answer. Basically, when you run a statement and there isn't a plan that's in cache that they can use, then they'll generate one. They'll then keep that plan in cache because they think of those plans as kind of expensive to have to regenerate, so they want to make sure that they get in cache and stay in cache and get reused. And there are some things that can clear all of your cache. These are things you're not going to do very often, like restart your server or TBCC free proc cache. If you make some reconfiguration changes, that can clear the cache. Some database level or procedure level things can clear database caches or procedure caches. There's even things that you can do to objects that might clear some of the cache. It's not really clearing though, we call it plan invalidation, where the plan stays in cache but the plan gets marked as invalid, and essentially it's not even exactly how it works, I'm kind of oversimplifying, but they make it in such a way that that plan can't get reused. So this happens when things like schema changes occur or statistics changes. But the point is, if there is a plan in cache, then we will use it. If there isn't a plan, then we've got to generate one. And then how long does it stay in cache? Well, these plans SQL Server thinks of as a little bit more expensive than data to have to put in cache, obviously, because they have to look at the plan, analyze the plan, use CPU, come up with the plan, put it in cache. So they will actually steal from your buffer pool and put that into your plan cache, essentially, if they have to. So how much goes to your plan cache is going to be dependent on kind of what's going on your server and the activity that goes on your server. But in total, quite a bit of your cache can actually go to the plan cache. And I put the actual math over here so that you didn't have to do the work. Basically in 2005 SP2 and higher, if you've got a 4 gig, 8 gig box, and I know some of you are going, what? Who would have a 4 gig or 8 gig box? Okay. If you guys are talking about a dedicated SQL Server, yeah, I hope you guys are running 128 gig or better. In fact, I have many clients that are running a terabyte of memory these days, okay? But I also have a lot of clients, probably way more, way more, that don't have a terabyte of RAM, and in fact have consolidated into virtual machines, and they've then limited their virtual machines to like 8, 16, or 32. And if you look at the amount of your cache that could be stolen from your buffer pool and allocated to your cache, that's kind of a big waste. Like if you have a 32 gig VM, now Windows and the OS essentially is going to use some of that, so it won't be exactly those numbers, but you could be wasting 5.8 gig of a 32 gig SQL Server footprint, which is a huge amount, especially if most of what's in that cache is single-use statements that only got used once. So I really want to stress that even though I just spent this whole webcast talking about ad hoc and SP execute SQL, they're really not my favorite way to execute, because you're either going to bloat the cache with all of those single-use statements that only get used once, right? Or you could end up with parameter sensitivity. And most of the time, the biggest problem is that development environments choose one or the other. They say, okay, we're going to do everything using Adhoc. They run into problems with it, so then they say, okay, we're going to move everything to SP execute SQL. And unfortunately, you can't use just one of those. You have to know when it's right to use one of them, but not one only all the time. So that's kind of my point of this session. If a statement's optimal execution wildly varies with the different parameters, then Adhoc is okay, okay? But if I'm being honest, if it's a high-end environment, I would much rather they use a stored procedure, because there's so many things that I can probably do better, control better, and track better if they move to things like stored procedures. Now, if the statement is a nice, single, stable statement, regardless of the different values that they might supply, then SP execute SQL is great. And in fact, I would absolutely, strongly suggest that they use SP execute SQL in that case. But I would still argue that a stored procedure would give us the same benefit of SP execute SQL, but with even more options, possibilities, and control. So to bring it all together, I think it's really important to understand the problems that are occurring because of all the ad hoc statements that are being generated. But for things that are really critical, I would really argue that centralized logic, reuse of your code, having compiled cache plans for stable code, and lots of other options in the way that you write those stored procedures is a much better plan for, you know, important critical environments. So I'm a big fan of stored procedures. And I have a lot of other resources that you guys can get access to here. Let me go through the resources, and then I'll stick around for the questions. A bunch of free resources on Pluralsight. If you email Paul, you can get that 30-day code. I would recommend, if you want to continue the content that we talked about today, starting with my Optimizing Ad Hoc Statement Performance course. I actually spend 7 hours expanding on what we talked about today with a lot more demos, forced parameterization, plan forcing with things like plan guides, specifically templatized plan guides, so all sorts of stuff there. After that, you might want to consider optimizing stored procedure performance, part 1. There is a part 2 as well, which goes into session settings and how they affect your environment. And then I've got a bunch of other resources here, white papers, blogs, and a bunch of blog posts that I did that can help you to analyze your cache with a whole bunch of queries to tell you what's in the cache, how many single-use statements are in the cache, how to clear the cache, and so forth. So lots of resources out there. I'm flipping back over. I think, let me just make sure that I don't have another resources slide. Oh, of course. Yes, I'm really glad I checked. I would really recommend, for those of you that want to go more into the stored procedure side of thing, I wrote a blog post called Building High Performance Stored Procedures, and it links to my past summit presentation from 2014 called Dealing with Multi-Purpose Procedures and Parameter Sensitivity Problems the Right Way. And it's a lot about what we've talked about today, but now in the context of stored procedures and how to make them as efficient as possible. So that would be a really good sequence to go through. It's a lot of content, but if you really want to thoroughly know this, like maybe even on your teams, dedicate one person to really knock all this stuff out and then represent some of it to the team, and maybe get them to watch some of these things as well. So just lots of different options. So let me grab my questions box here. Wow. There we go. Let me see if I can make this bigger. Yeah. Whoa. Okay. I got time. Let's see. Will this presentation be recorded? Yes. SP is repeatedly running for reporting with less query cost. Where consuming maximum resources? I'm going to need more details on that one. Let me do the ones that are specific to this session today, and then I will see if I can get to those others. Auto-parameterization and cache plans. What happens when you have a stored procedure with one or more parameters that contains a conditional logic, right? Yeah, okay. So they're asking what happens in a stored procedure if you have conditional logic. This is a great question, and it's unfortunately probably not the answer you want to hear, but at optimization, so you know what I'm going to do? I'm going to come over here into Management Studio for a second. There are 5 phases that a statement or even a stored procedure goes through. They go through something, parsing, obviously. They go through parsing first. Then they go through a process that's often known as standardization, normalization, algebrization, and they end up coming out of this with something called a query tree. That query tree is then optimized. That's the next step. So they go through optimization. Then after they come up with a plan, they compile that and then they run it, right? So these are essentially the 5 primary phases that you go through when you execute something, especially the first time, because the first time is when it gets optimized. Well, optimization, when they look at things like conditional logic, they don't know how the parameters that you've passed in are going to cause the branching to change, because they won't know that until they execute the condition. And they won't execute the condition until down here. So at optimization, SQL Server, this is going to sound kind of strange, but they optimize everything that's optimizable. These are like barely words here. There we go. Make that color coding look a little better. But they will optimize everything that's optimizable. So what they do, even if you have conditional logic, if stuff, right, I mean, obviously, SQL, else, other SQL, right? And of course, you could have a begin-end block and all that. I'm just trying to get through the question, right? But they don't know if this SQL is going to be executed or this SQL is going to be executed. So they will look at your parameters, and if that parameter can be used in that statement, they will optimize both of those statements with that first execution's parameter, even if ultimately they're only going to execute the if statement or the else statement. So even though SQL Server does this optimization to everything that's optimizable, you might not yield an optimal plan. So I have a large section on my stored procedures course on Pluralsight on how to better deal with conditional logic, and options way better than this would be things like modularization. I mean, that could help. You could use some hints. That can help. There's pros and cons to that as well. You really don't want to have, though, a lot of conditional logic without any hints and without modular code, because you will end up with inoptimal plans. Okay, so I got that one. Can there be tables and joins? Will it auto-parameterize? Nope. It will not auto-parameterize if there's any joins. You can list only one table in the entire query. Okay, there's a bunch of questions in here that aren't related to what we're talking about today, so I'm going straight to the other ones. As far as where the scripts and the archive's going to be, Rob, can you address that for a second?
Sure. Can you hear me okay?
Yep.
Okay, great. So on the past data architecture chapter, we have an archive page. On the very top of the page or near the top, we'll have a link to the downloads. And also on that page, I'll have the YouTube link for this session. So if you just go to the archive section for data architecture, kind of scroll around, it's going to be really evident because it'll say, the zip file or whatever I'm given. It'll be one place. And then the YouTube, you can go subscribe to data architecture and also see it, or you can go through the link there.
Cool. Thank you so much.
Oh, you're welcome.
All right, let me keep looking for more questions that are related to what we're talking about today. Is there a property in the execution plan that will tell us if SQL Server considered a plan safe or unsafe? The words safe and unsafe really don't appear anywhere. It's only if it's parameterized and reused that it is safe. Otherwise, it's not safe. There's a whole section in that appendix in the white papers that I listed. In fact, there's ones for like 2005, 2008, 2012. So there's different versions of the white paper that explain all of the criteria, but I don't think it's listed anywhere as to whether or not it was safe or unsafe. It's basically just, was it parameterized or not? So you can actually look in the cache to see if the plan has a literal or has a parameter. If it has a parameter in the cache, then yes, it's been parameterized. If it has a literal in the cache, then nope, it's unsafe and it's every time. But there's no property in the execution for that. Someone says, I thought SP execute SQL was used to combat SQL injection. That is what a lot of people think, and it certainly reduces SQL injection by strongly typing the parameters for you, but it's not only the, it's not, how do I want to phrase this? That's not really the only difference at all. The biggest difference, in my opinion, is the caching aspect. So, I'm trying to figure out how a third-party app works. It runs a ton of SP execute. How do I track back the handle to an actual query? You can go back to the cache, and the plan handle is one of the other columns in the query that I executed. So you can take that query from that stored procedure. Since I'm still on this window, I'll scroll up, and you can actually take this query and pull out stuff from the query statement, the statement handle, and the plan handle, and reverse engineer the statements from there. So that's actually a great way of doing that. With parameters, using an average based on statistics, does this behavior change when filtered statistics are present? Yeah, Tyler. Hey, Tyler. This is an interesting question. Filtered statistics, you know that I kind of have a love-hate relationship with these. There's a lot of places in SQL Server where they don't do the right thing yet with filtered stats, and I'm still hopeful that they're going to get better and better with filtered stats, but the biggest issues around even getting them to use filtered stats are things like the environment, your session settings. If it's in a stored procedure, you need to use things like option recompile, which, having said that, if you're using option recompile, it can use the histogram, so it won't use the average or the density vector. And there's a lot of statements where, in fact, I kind of wanted it to use average, but you can't get it to use average because of option recompile. So I don't know if that's answering it, but I guess the long story short is they're not getting those better averages because of option recompile. And I have some cases where I've done that and shown that. It's kind of weird, but I think that should answer it. Let me know if you have more here at the end. I'm still watching the questions. Okay, so does index rebuild reorganize cause recompiles and thereby regenerate the plan? This is a great question. An index reorganize does not. An index reorganize does not touch in any way, shape, or form statistics. An index rebuild does rebuild the statistics and update the statistics. So any statements or procedures that leverage those statistics that get updated, those will end up becoming invalidated. But there's even some other funky things that go hand in hand with that. But yes, an index rebuild will cause the plans to be invalidated. So on the next execution, you'll get a recompile. So that's the answer there. How about tempdb? Any special considerations? Cannot shrink. I don't know of this one off the top of my head, but it's not related to plan cache. It's probably related to the buffer cache. So we'd have to look at that a little bit more. This one is a good one. Sarav, your case statements and CTEs. Yeah, that could be a whole presentation in and of itself. But the question here, how does SQL Server optimize and keep those plans in cache with things like case statements and CTEs? And this is a whole nother can of worms. Simply put, you probably want to use things like recompile on statements that have case statements to ensure that you get better, more accurate plans, but it would depend on what the case is that you're building. Is it a case in the select list? Is it a case in the where clause? That can get really troubling. I would argue that, no pun intended, but on a case-by-case basis, you'd really have to do some testing to get the right plan for that. And CTEs, in a lot of cases, a CTE is great for correlated subqueries, but when you have something that's incredibly recursive, I would argue that you may want to consider stored procedures and recursive procedures to analyze the code rather than a recursive CTE. But again, that's a lot of trial and error and testing, and it's, again, kind of on a case-by-case basis. That's a tough one, Sarav. It's a good question, though. It's that one there isn't a good answer. When should we use with recompile in a stored procedure? Let me say this, not as often as it's probably getting used, a lot less often than I'm seeing. I tend to recommend only using with recompile inside of a stored procedure, first of all, as a Band-Aid fix. In other words, you've got a stored procedure, you're seeing horrible execution times, you know it's due to the parameters that are being passed, and you're just trying to come up with something better. So finding the offending statement in the stored procedure and adding option, oh, wait a minute, I'm sorry. I'm saying option recompile. You're asking about create with recompile. Okay, let me finish the option recompile scenario and then I'll actually answer your question. But option recompile, I tend to use as a Band-Aid fix. I put that in to fix the offending statement so that just that statement gets recompiled. Now here's the bad news. Long term, that statement's going to get recompiled on every single execution, every single time, and that may not be a good idea. What you might want to do instead is more selectively only recompile for parameters that really need a recompiled plan, and then let a nice stable plan stay in cache for the parameters that might have some stability. And that's what I spent my entire past presentation and that link that I pointed you guys to, building high-performance stored procedures, that directly discusses that question. Okay, so I definitely look at that for a better way to deal with recompilation rather than just adding option recompile everywhere. Now the real question is, when should we use with recompile in the stored procedure definition? Never. Boy, I wish I had read that question right the first time, because that answer is way easier. Never, ever, ever, ever do I recommend creating a stored procedure with recompile. And I know that sounds adamant because it's very rare that any of us say always or never with SQL Server. But specifically, when you create a stored procedure with recompile, it does not do as good of an option as option recompile does, first of all. And that might sound hard to believe, but I promise you there are things that option recompile can optimize at the statement level that creating a stored procedure with recompile cannot. But that's not even the main reason. The other probably main reason is that when you create a stored procedure with recompile, neither the statements nor the stored procedure go into dmexec query stats or dmexec procedure stats. And as a result, it becomes much more challenging to troubleshoot those plans. Whereas if you do option recompile, the statement goes into cache and you can see that statement, you can see the executions, and you can see the last plan. So I'm a huge fan of option recompile, but not with recompile. Great question. And the last one here, do we need to clean up these individual plans manually, or are they cleaned up at some point? The unfortunate part is they're not really cleaned up until cache reaches certain limits, and unfortunately I usually don't want to wait that long if most of my cache is filled with single-use plans. So if you remember that page on plan cache pollution resources, I have in here plan cache and optimizing for ad hoc workloads. I'm going to click on it and see if I can show you the solution that I have to this problem. At the very beginning, I give you a query to have you look at your cache, and then in this same post series, let me actually I will do this plan cache. So I'm going to go to the category plan cache right there on the right-hand side, and from the bottom up, okay, so there's that, plan cache and optimizing for ad hoc workloads. Plan cache, ad hoc workloads, and clearing the single-use plan cache bloat before you end up wasting so much memory. That's the one. I talk about the numbers that I got from a variety of people which show a tremendous amount of their cache being wasted, like just literally being wasted. And then at the end of it, I show a couple of different things that you can do. You could clear just the SQL plans. You could clear all of your cache, which no, I don't recommend. And if you're on 2008 and higher, actually I should have said 2008 or higher, I put a little script together that will allow you a better way even to automate this by putting something into a job, and you can see that if you play around with that script. So yes, I do recommend that you end up looking at your cache, and let's say, I'll do one more thing here. These are great questions, you guys. Let me go back to this slide for a second. This one, okay. Imagine you're on one of these consolidated boxes, 4, 8, 16, or 32 gig. I don't want to waste 5.8 gig if most of that is single-use plans, so I'll use my code that I just showed you in those blog posts to create a job that will analyze the cache, and when the cache gets to, let's say, a gig of single-use plan cache, then I'll clear the ad hoc and prepared plan cache, but not the stored procedures or anything like that. So I actually show you how to do that in that blog post series. There's something called DBCC free system cache, and you can pass in a parameter called SQL plans, and you'll end up just clearing the SQL plan cache, which is very, very cool. So I would definitely recommend for those of you that are administrators or operations, analyzing the cache through a job and then regularly clearing the plan cache bloat. And I actually have customers that check the cache every half an hour. And if it doesn't have to do anything, fine. Checking the cache is very cheap. So we check the cache, and if it's over a gig, we clear the plan cache bloat. And so on those smaller boxes, for sure, 4 gig, 8 gig, 16 gig, I probably wouldn't even let it get over 512 meg. When you get to 32 gig, maybe 64 gig, I'll let it get up to a gig, but not much more than that. And then on a bigger box, to be honest, 2 or 3 gig, and I'm going to want to clear it there too. So, and then finally, last question. How much performance difference between a plan which is cached versus a plan which is not? That's a great question, Jan. And it's going to differ from statement to statement. There's no simple way to answer that. The only difference is the cost of compilation, because the runtime, the execution, is going to be the same. So you could argue the biggest chunk of the whole process, which is execution, probably won't change, but caching is not just time, it's also the impact on CPU. So I kind of think of it as it's affecting two things. It's adding a little bit of time, it's maybe eating more into our CPU, and the more things that we have that are eating into the CPU, the more we can start having a CPU bottleneck, not just an I/O bottleneck. So I still want to be choosy with, you know, what has to be compiled every single time. Okay, and I got a new question after that. So this is now going to be my last question. A little bit about the plan cache and views. The best news, and the reason why I'll answer this one very quickly, is that views are just named saved selects, and that select is going to be treated just like any other select. So it's going to depend on where that select is. Is that select in an ad hoc statement? Is that select in an SP execute SQL or a stored proc? But it's then going to be affected by the way an ad hoc statement is dealt with or a stored procedure or SP execute SQL statement is dealt with. But the fact that it's a view is somewhat irrelevant. I will add that views can complicate the process of optimization, and they can make getting an optimal plan more challenging, but whether or not we save that plan and how we deal with that plan will be dependent on how we access the view, not meaning ad hoc or stored procedures or SP execute SQL, as opposed to the fact that it is a view. So, and with that, I've got all of the questions related to the stuff we talked about today. There's a few other questions that I think are a little bit more targeted to other topics or forums. So I think we're pretty good here. Rob, I don't know if you want to say any closing statements, but after you do that, I'm going to sit at my desk, wrap up all these resources right away, and probably within a half hour or so, I'll get them off to Rob, and then, you know, he's got to go through the channels to get this up onto the website. So it will be there shortly, everyone, and I really appreciate you guys. Oh, and thank you for all the thanks that people are saying. Yeah, you're welcome, everybody. And thank you very much, Rob.
Okay. Thank you for coming. I mean, it's wonderful presentation today. Absolutely
Thanks,
wonderful. So I'm going to try to get all this up in the next day or two to YouTube and put it on the architecture site, and everyone will have access to it. Actually, I think we set a record here. We almost hit 200 people online. We had 199 people online.
Right on.
I've never seen that many people come to our chapter and watch a webinar. So thank you, Kimberly, and thank you everyone for coming. And,
yeah, thank you very much, everyone.
And that's all I really have to say. We have some more great webinars coming up, and I told Kimberly she's always welcome to come back, and I'll just wrap it up with that. So any questions I get after this, I'll be glad to forward on to Kimberly, or you know, y'all can email her.
Yeah,
do you have your email up there?
It's on the first slide.
Okay,
and
great.
Probably the second or third as well. So it's in there a couple of times. Okay,
great. Well, I guess we're all done. I'll help everyone have a great day, and talk to y'all later. Thank you, Kimberly.
Thank you.
Bye-bye.
Bye-bye.